Okay, angles of rotation. We're going to talk about the different angles that we work with our triangles and also with the coordinate plane. There's quite a little bit of terminology in this, so you need to make sure that you pay attention to the terminology. It says an angle is in standard position when its vertex is at the origin and one ray is on the positive x-axis. So this is an example here of an angle in standard position. The positive x-axis is at 0 degrees. Okay, that's in standard position. The initial side of the angle is on the x-axis, the positive x-axis, and the other ray is called the terminal side. So we have initial side here for this angle of positive rotation, which goes counterclockwise. Right? So if you have an angle with positive rotation, it goes counterclockwise. If it has negative rotation, then it's going to go clockwise. So positive angles go counterclockwise, negative angles go clockwise. All right, remember that. So if we're going clockwise, we go at 90 degrees, 180, 270, 360, and so on, and it keeps going. Okay, you can go around more than once. Same with negative. Negative 90, negative 180, negative 270, negative 360, and it can keep going. Negative 450, negative 540, and so on. An angle of rotation is formed by rotating the terminal side and keeping the initial side in place. If the terminal side is rotated counterclockwise, it's positive. Clockwise, it's negative. Okay? Right here they show us an example of an angle that is a positive 390 degrees. You'll notice that it's gone around more than once. Okay? Goes around one full revolution plus another 30 degrees because 390 is 30 more than 360. Notice also that when they show the angle, all right, there's an arrow there, right, that they show when they go to the terminal side, there's an arrow that shows where it stops at. But that's specifically to tell you which direction it's going. So first we're just going to draw some angles. Now, if I'm halfway between any two of these lines, how far is that? How many degrees? 45. Okay, 45 degrees. All right, so you need to think about that. That I'm always, that the middle is going to be 45 degrees. So if I'm less than 45, make sure you express that correctly. And if you're more than 45, express that correctly. Okay? So this says a positive 320, which means I'm going to go counterclockwise. Okay? So I'm going to start here. Here's my initial side of my angle. And I'm going to go clockwise, or counterclockwise. So 320, how far is that from this positive x-axis again? All the way around is 360, so that's 40 is a little bit more than 45, right? Or a little bit less than 45, excuse me. So when I draw my angle then, I'm going around this way, and I should be just a little bit past halfway here. And notice that I have an arrow here.
Below 45 though?
Nope. 345 is not halfway. 315 is halfway.
Oh, okay.
Right, because this is 360 here, right? Not 390. Okay, so this is 320 degrees, positive. All right, goes around clockwise. Make sure that you show the arrow here that it's going that direction. Negative 110 degrees. Right? So if it's negative, we're going clockwise. So we start here. Here's 90. And then we're going to go a little bit past 90 then draw our angle. We're going to show that it is clockwise is the way it's going. This goes clockwise 110 degrees. 110 is 20 past 90, so I just need to go a little ways past 90 degrees to show it. And your arrow is only at the terminal side, not at the initial side. So 990, it's positive, so I'm going to go around clockwise. So one time around is how far? Okay, 360. I go around again, I'm at what? 720. Okay. So, all right, how much farther do I need to go to get to 990 from 720?
degrees.
270 degrees. Where's 270 degrees at? Okay, directly south, right? All right, if you want to talk about it that way. So I've got to go this much farther, draw my arrow there, and that would be there's my terminal side, here's my initial side. That shows an angle of 990 degrees positive. So the quadrants are going to help us. Knowing 90, 180, 270, 360 is going to help you. So we're going to look at something that's called coterminal angles. In coterminal angles, they terminate at the same spot. The only thing is that they differ by a certain amount. Okay, well, how far is it around the circle? 360 degrees. So coterminal angles actually differ by multiples of 360 degrees. Okay? It might be exactly 360. If you look at this example here, they show 120 and 240 degrees on this graph. Positive 120, negative 240. They both stop in the same spot. They terminate in the same spot, which means that they are coterminal angles because they differ by 360 degrees or multiples of 360. So if I went around one more time here, so if I went this way then and went back here, that angle is also coterminal. Okay? It's just that that angle then is negative 600 degrees. Because that would be 240 plus 360, right? Or negative 240 minus 360 would give me a negative 600. So that angle is coterminal with those other two because they terminate at the same spot. They differ by multiples of 360 degrees. So this is real easy. Find the measure of a positive and negative angle coterminal with each angle. So what do I need to do? Take 65, add 360. That'll give me a positive one. Take 65 and subtract 360 to get a negative angle. So 425 and negative 295 are coterminal with 65 because they differ by 360 degrees. Positive or negative, doesn't matter which. Okay. Because they will terminate at the same spot. They will all terminate at about this spot right here. One of them going this direction and one of them going around more than once. (410 degrees). Now, anytime, so to find a terminal or angles that are coterminal with 410, so do the same thing. Add 360, subtract 360. And I get a positive and a negative angle that are coterminal with 410, right? Do I get a positive and a negative one? Oh, I got two positives, don't I? Well, then how can I get a negative one? Josh? Okay, or just subtract it by 360 again, right? So if I'm looking for a negative one, and yeah, that works. Okay. If I get a negative one, or if I don't get a negative when I subtract, then I need to do it again, or again, until I finally do end up with eventually getting a negative angle. Okay. So 770 degrees, negative 310 degrees. So my answer actually for the positive ones could have been either one of these two. I could have used 770 or 310. Or 50, excuse me, for my positive angle. Basically, it's up to you. If this number here is bigger than 360 or smaller than negative 360, then you can just keep going the same direction to get your positive and your negative one. All right. Something called reference angles. A reference angle is an angle, a positive angle, less than 90 degrees. It's a positive angle less than 90 degrees. And a reference angle is always found by how far an angle is from the x-axis. Okay? Whether it be positive or negative x-axis. Okay? Just how far is it from the x-axis? And since we're talking about distance, how far is it? We're talking about a positive number. So here we have 135 degrees. Which quadrant is 135 degrees in? Okay, it's in the second one, right? Upper left. Okay, so positive 135 degrees is this angle that goes approximately here, right? Okay. So when they're asking me for the reference angle, that means I want to know how far is it. Oops, I can't use it. Theta. How far is this from the x-axis? So what angle is this one right here? What's the x-axis? What angle is that? Okay, 180. Right? So here I've got 135. How far is 135 from 180? So we just need to do some subtraction. 180 minus 135. Okay, and that's 45 degrees. So the reference angle here is 45 degrees. That's how far the angle is from the x-axis. Okay. Negative 105. Which quadrant is negative 105 in? Okay, Leela? Third quadrant. Okay, we're going to start, go clockwise. Here's 90, so we got to go A little bit past that 90. Here's my angle. So I want to know how far is that from the x-axis. So in this case, this is negative 180 degrees. So how far is negative 105 from negative 180? Okay, 75 degrees. It's always positive.
It's always going to be less than 90.
And always less than 90.
So it can't be equal.
It cannot be equal to 90. It must be less than 90. Okay. Let's see where to go. Standard is a positive acute angle. And acute angles are less than 90 degrees. Okay. There are no reference angles for on the y-axis. Okay. And we're going to be talking about something called the unit circle that you're going to memorize. You'll really appreciate that. Okay. And when we do that, that's a little bit, you'll see why reference angles don't make sense there. Okay. 325, that's in the fourth quadrant. Over here. So I want to know how far is that from the x-axis. And so in this case, it's just short of 360. So 360 minus 325 is 35 degrees. Would be my reference angle. Distance, the angle is from the x-axis. Now, this is the last part, and this tends to be the hardest, okay, from this lesson. But if you use the letters that they give you to figure things out, it really shouldn't be that difficult, okay? You can simplify it really easily. So you need to write down this stuff here, okay? So we have a point. Call that point xy. Huh. What a concept, huh? Point being xy. We have a right triangle that we're drawing. We have the x is our horizontal length for the triangle, or is going to be the adjacent side of the right triangle. X is always the adjacent side. Y is the opposite side of the right triangle, always. Okay? And then we have this letter R, which represents the hypotenuse. Well, not only does it represent the hypotenuse, but think about it this way. Right? What did I just kind of draw? A circle. And what does R represent on a circle? The radius. So really, when we're talking about R, we're talking about that they've drawn a circle through that point where the center is at the origin. Okay? And R really represents the radius of the circle. How do I find the radius of this circle? I use the x and y to find it. Pythagorean theorem. So R, the radius, is equal to square root of x squared plus y squared. And then we have three new definitions for sine, cosine, and tangent. Very simple. Sine, y over r. Cosine, x over r. And tangent is y over x.
So we're always going to be given that point.
In these problems, they're going to say, okay, here's the point. Find the 6 trig functions using that point. Okay? And y always goes with sine, x always goes with cosine. Okay? Because y is always going to be representing the opposite side of the triangle, and x is always going to represent the adjacent side. Always, 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 always. So when you go on farther, that'll always be the case. All right, so I'm actually going to Well, I'm going to draw this, but we're going to do it without it. So it says the point negative 6, 9 is a point on the terminal side of Q in standard position. Find the exact value of the 6 trigonometric functions for theta. So I have the point negative 6, 9 right here. And what we're doing is we want to find each one of these 6 trig functions, but there's my right triangle. The adjacent side is always x. The opposite side is always y. If it was in the third quadrant, then the triangle would look like this. Same with if it was in the fourth quadrant, the triangle would look like this. Right? But you really don't have to worry about the triangle, and I'll explain why. Well, the reason is because they tell us, right, we just need the formulas. We just need to have the point and find r. So let's find r. Square root of x squared plus y squared. Jocelyn, now that you're awake, right? What happens when I square a positive number? What do I get? Again, even bigger number. Is that even bigger number going to be positive or negative? Positive, okay? All right, good. All right. How about if that number is a negative number, what's going to happen? It's going to be positive, okay? Because if I take negative 6 times negative 6, I get positive 36. So please, okay? Please don't forget that, right? Because some of you do. Right? So r is the square root of negative 6 squared plus 9 squared. So this is 36 plus 81, which is this lovely number 107, square root of 117. Okay? A really nice, ugly number. Okay? All right, but I'm going to help you out here. Now, so we want to find sine, cosine, tangent, cosecant, secant, cotangent. So this is what you do. You write sine first of all. Sine of theta equals. Put underneath that cosine. And underneath that tangent. Okay. Write those 3 first. This is what helps me. All right. Sine is opposite over hypotenuse. Okay. Y over r. Okay. Cosine is x over r. Tangent is y over x, or negative 3/2. Now, if you get a big radical number, okay, like this, just leave it, okay? I'm okay with you leaving that in the denominator. All right, I'm not going to fight with you on them because I know that's, some people have a real hard time with them, so just leave it there. Okay, if you want to write it so it's out of the denominator, that's fine. Okay, should be able to do that. But now I need to find the other 3. The other 3 are very simple.
So
Okay.
we want to write it out of the denominator. We're going to have to do time square root.
Yeah, this would be 9 square roots of 117 over 117. Okay, so basically all you're doing is taking the denominator, writing it next to the numerator, and putting the denominator there without a radical. Okay, it's really pretty simple. Cosecant. Hey, cosecant is, I'm writing it next to sine because it's the reciprocal of sine. So cosecant is square root of 117 over 9. Flip it over. Secant is the reciprocal of cosine. So that's negative square root of 117 over 6. I write those next to each other because they're the reciprocals. All I got to do is turn over. Flip over top and bottom. Cotangent, negative 2/3. And they're done. Okay? So in reality, the only thing you need to find here is r. Once you find r, then you just start plugging in x's and y's and r's where they go. Sine y over r. Cosine x over r. Tangent y over x. Plug them in.